All right, as promised, we're circling back to lesson 12.4, completing the square. Pause the video and make sure you have paper and pencil. There's some notes that you're going to need to take down for sure. Okay, so first of all, we're just going to take a quick look at this visual down at the bottom of the page. You can see we have x squared plus 6x. So this represents the x squared. Here is the 6x, and then we just rearranged it. And to complete the square, we need to find out what goes inside here. And it's demonstrated with tiles. And I'll show what it would look like numerically, but with a different expression. So we're going to complete the square. What we need to do is we need to find the constant that goes here, and we don't know if it's plus or minus. So we're going to take half of the linear term, and it's the linear term because it has an x. The x squared is the quadratic. We take half of that and we're going to square it. So that's it, x squared plus 20x. So we said 10 squared is 100, so we completed the square. But we're going to be solving using completing the square, so it gets to be a little bit more complicated. Notice that we have x squared, we have the 100, that this one can actually be solved by factoring. So if I factored it, it would come out to x, the quantity, x plus 10 squared. All right, so we're just working with quadratic equations, and we already know we can solve some quadratic equations by finding the square root. If I had something like x squared minus 4 equals 0, we could write x squared equals 4 and then find the square root of both sides. Graphing, we know if we're graphing, our parabola can open up or down, and where it intersects the x-axis, those are the solutions. Our quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. We just looked at this one, factoring, and then today we're going to be examining completing the square. So depending on the values given, or maybe your preference, we have various ways we can solve quadratic equations. I would pause the video, and we're going to write number 1 and number 2 down. Things that you need to know: we have to make sure when we're completing the square that the constant has to be moved to the other side of the equal sign. And then we also have to make sure that our coefficient of the squared term is equal to 1. So if I had something like 2x squared plus 4x minus 7 equals 0, the first thing I would need to do is make sure that the 7 is on this side. So we added 7 to both sides. And then we also have to make sure that we're dividing everything by 2 so that our leading coefficient there is going to be a 1. All right, so let's try one. All right, so I'm looking at this one, and I'm kind of happy because I can see that the coefficient in front of the x squared is a 1, just like it should be, and my constant is on the side all by itself. All right, so now we're going to complete the square, and what we did on our first slide, we said let's take half of 10 and square it. The difference is, now that I have an equal sign, remember what I do to one side I have to do to the other side. Okay, so we ended up getting half and squaring it, and then half and squaring it. I had to do it to both sides. Also notice I left it as an exponent, and the reason is when I go to factor this, it's super easy to factor. I just grab the x and I grab this base. And this is not a difficult one, but later on when we're working with fractions, you might be grateful for this little trick. Okay, so I factored the left-hand side and I simplified the right-hand side. Now we need to get rid of the 2, so we're going to square both sides and subtract 5 from both sides. And remember, just like when we have our a graph, not every single time, but oftentimes we have 2 solutions. So you're going to say -5 plus 7 and -5 minus 7. And those are our 2 answers. And I'm sure some of you are saying, hey, wait a minute, if I go back up to, if I go back up to the first part and I move over the 24 and say x squared plus 10x minus 24 equals 0, why can't I just factor it? Find out what multiplies to -24 and adds to 10. And of course, we can get the same answer. Using our zero product property, we would get -12. Use our zero product property, we get 2. But not every problem is going to be factorable. The example, I wanted to use simple numbers. The example happened to be factorable, but we're going to look at a little bit more challenging one next. We already talked about the different ways to solve quadratics, but if you didn't write them down earlier, you can pause and write them down. All right, so here we go. So think to yourself, what's the first step? I noticed that -7, it's on the wrong side, so I'm going to move it over. I also notice that I have a 3. So I'm going to have to, at some point, divide everything by 3. So I either divide everything by 3 now or once I move the 7 over. Okay, so now we have it in the proper form. The next step is where we actually start completing the square. We're going to find half of 5/3. So in your mind you say 1/2 of 5/3 is 5/6. And then remember, so here's the half. And then remember we're going to square it and write it on the left and the right hand side of the equation. Now, this might be a time where when I said, oh, now because I left it with an exponent, I can just grab this base and then grab this x, and it's easy to factor. This is the side that's going to be a little bit more complicated. We say 5 times 5 is 25, 6 times 6 is 36, so we have to add 25 over 36 to 7/3. So we have to find a common denominator, which is going to be 36, and in order to get the 3 to be 36, we're going to multiply by 12, 7 by 12, so we get 84 over 36, so now I can add the 25 to the 84. Then we need to find the square root of both sides. And again, remember, I told you to take out pencil and paper. I hope you're pausing the video and jotting down these steps. I'm going to find the square root and the square root of this side. Remember, when we find the square root, we have plus or minus. Now we're going to subtract 5/6 from both sides. And this denominator, the square root of 36, because if I say the square root of 109 and then the square root of 36 is going to be 6. So I can write it as one big fraction answer because I had a common denominator. So this answer, it looks a little bit more complicated than the first one that we did that I said you could solve by factoring. So we have plus the square root of 109 minus 5 over 6 and then minus the square root of 109 minus 5 over 6, or negative. All right.